the problem, a mass 2 kilo. So let's say this is the bob, and mass of this bob is 2 kilo, which is suspended at a point O. So this is the point O, this point by OA string. So here this string is OA, OB, and OC. OA equals to OB is equals to OC. These three lengths are the length of the string, which is 10 meter, and angle between COA. So the angular amplitude, the maximum amplitude up to A, and the angle is 60 degree. So angle of COA is 60 degree. This is also given, and the height traveling from C to B or B to C, the height is 3.75. So this is the point. So this is OC, and if it is traveling from C to B or B to C, so the height, you can see the displacement height is 3.75. This is given in the question. Anyways, the main important point is neglecting the friction and air resistance. So there is no air resistance and friction traveling from O to B, B to C. There is no resistance. Anyways, now the very first question, what we have to do, we have to determine the tension of the string at point A. So at point A, we have to determine the tension of the string, right? And obviously, when it is moving, not during the static time, or when the bob is at A point, not that time. When it is traveling, it means that when it's releasing from A point, at that time, what is the tension at the string that we have to calculate. To understand the concept, we have to understand the tension force. So here the weight of this string W is equals to mg, and obviously this is the point A, let's say. So in this direction, the force will be mg, or the tension force will be mg cos theta, and here obviously the theta, and between this angle is 60 degree, which is given within the question. Anyways, and the mass of the bob here, so here is the bob, here is the bob, so mass of the bob is 2 kilo, and this is actually that mass of the bob, and g is acceleration due to gravity, and g is obviously 9.8 meter per second square. And what we have to calculate, we have to calculate the value of tension. Here the very important point is the weight of the body, that is actually W equals to mg, which is actually towards downward direction, and tension of the string component of weight along the string, which is this much. So the tension T is equals to, we could write down mg cos theta. So here the value of m is 2, value of g is 9.8, and the value of theta, so this theta and this 60 degree is same, so obviously we have to plug in the value of 60 here. So here the tension of the string is 9.8 Newton. So here the tension force will be 9.8 Newton during its traveling from A to B, B to C, blah blah blah. Anyways, now it's time to calculate the second part of the question, which is according to the theme, will be the kinetic energy of point C differ from B? So we have to calculate the kinetic energy at point B and point C, and we have to check whether the kinetic energy for both the point B and C is equal or not. B number solution, we have to understand this is point O, and we have to draw this length. So let's say this is D point, and from B this will be, let's say this is E point. Anyways, now OD is equals to, we could write down OA cos 60 because D is 90 degree, and from here we found the value of OD is 5 meter. Again, the value of CD. So this is C and this is D point. So CD is equals to OC minus OD. So OC is 10 and OD is 5. So we have got 5 meter. So CD, so this length is 5 meter. Again, we have to determine the value of D of E. So where is DE? DE is this much, right? So to determine the value of DE is nothing but CD minus CE. So CD is 5 and CE is equals to 3.75, which is this much. So we have got 1.25 meter. Right? Now, the kinetic energy at B point, so EKB is equals to half mv square. Let's say this will be, let's say, B point. So to determine the value of VBB, so here the value of VB, and obviously VA is equals to 0 meter per second. Indeed, so here VB square is equals to VA square plus 2G, and the height is nothing but DE. So height is DE. So of course this is 0. So V square is equals to 2G, and DE refer 1.25. So here 1.25 meter. Now here half mvb square means 2G and 1.25. So 2 to cancel out. Value of m is 2, 9.8 and 1.25. So here the value will be so here the value will be 24.5 5 meter. Now it's time to calculate the kinetic energy for EKC. So here will be same as mvc square, right? So we have got the value of VB. Indeed, VC square, it means, let's say this is VA, this is VB, and this is VC. So from traveling from VB to VC, so here VB square plus 2g, and the height will be CE. Now plug in the value of VV square is nothing but 1.25 times 2g. So this is the value of VB square, and plus 2g, the value of CE means 3.75. Or here we could write down 2g, so 4, and here will be 5. So here is 10g, the value of VC square. So let's plug in the value of m is 2 and VC square means 10.9.8. So this to cancel out. So it will be 98 joule actually. And here, beg your pardon, here should be joule as well. Anyways, so kinetic energy at B is not equals to EKC. So of course, when traveling from B to C, from A to B, B is about 25 joule and C is about 100 joule. So of course, at C point, maximum amount of kinetic energy we can observe. So we can write down as well, EKC is greater than EK. So this is the final answer for this problem.